So this is the part 2 of the rectilinear translation, which is your rectilinear motion. Now we're going to discuss about the free falling bodies na ano na like way of motion. Rectilinear siya pero pa downward or pa upward yung movement niya sa free falling body. So what are the free falling bodies? So it is a special case of rectilinear or straight line motion with constant acceleration. Kumbaga yung constant acceleration dito is due to gravity. So most of the time, if we are talking about free falling bodies, we're going to use the G or the constant ng acceleration due to gravity, which is 9.81 meters per second sa SI or metric and 32.2 sa US customary. Now, motion of a body where its weight is the only force acting on an object. Only yung yung timbang out, like yung weight niyang talaga, bakit siya nagko-cause, bakit siya nag-move. Ayan. So in kinematic equation for object experiencing free fall, you can use this formula, which is V is equals to V sub O minus GT. Basically, yung AC doon, ni-replace lang ng G since yung constant acceleration niya dito is experienced by gravity. So, for your 2.7, equation 2.7 is V is equals to V sub O minus G times T. S is equals to S sub O plus V sub O times T minus 1 half GT squared. And lastly, V squared is equals to V sub O squared minus 2G times S minus S sub O. So, let's have an example of a free falling body. So, during a test, a rocket travels upward at 75 meters per second, and when it is 40 meters from the ground, from the ground, it, as you can see here sa figure or sa drawing. So, when it's 40 meters from the ground, its engine fails. Its engine daw fails. So, I mean, tagat mo nalaglag ulit siya to the ground. So, determine the maximum height as a B. Now, as a B because we assume that there are three positions here from the origin. Yeah. So we have position A, position B, and position C. So what is the maximum height as a B reached by the rocket and its speed just before it hits the ground? While in motion, the rocket is subjected to constant downward acceleration of 9.81 meters per second squared due to gravity. Now, neglect the effect of air resistance. Now, in this problem, we have required two requirements. So we have to solve for the maximum height and the speed just before it hits. Just before it hits, wala pa siyang hit. Wala pa siya na hit sa ground. So there are two parameters we are going to solve for this problem. So given this figure, we have to assume that position A, position B, and position C. Maximum height reached by the rocket at position B. What is the total height from the ground? And then speed just before it hits the ground dito sa position C. So to solve that, the origin O for the position coordinate is taken at the ground level with positive upward. Now in this manner, we assume our origin to be at the ground, and then yung pa-upward na mga motion will be positive and yung pa-downward will be negative. Okay? So let's solve for our first requirement. So we have determined the maximum height S sub B using 2.9, what we have given kanina sa mga formula if you're dealing with free falling bodies problems. And so we assume that upward motion is positive. So we have V squared sub B is equals to V squared sub A plus 2AC or 2G. But in this problem, it is specifically given, that acceleration is due to gravity, which is AC, times S sub B minus S sub A. So, why we use this formula? Kasi yung given yung velocity, initial velocity at point A. And we are also given sa velocity at point B. And we also given by initial position at A. So we can solve SB directly by just substitute all the values that are given. So to solve that, you're just going to substitute the given. Now, why does the velocity at point B became 0? Of course, ni na mention sa problem that the rocket's engine failed. So we assume that hindi na siya nag-accelerate, 'di ba? It suddenly stopped at that point, 'di ba? So we can assume that at point B, biglang nag-fail yung engine niya, hindi na siya nagbigay ng um, upward force to move the rocket in another position. So we assume that its velocity reaches zero at point na nag-fail yung engine niya. So we can assume that find out the maximum height niya, dun din yung biglang huminto yung engine. And we assume that at point B or at the maximum height ng rocket, zero yung velocity niya since it doesn't move upward na because of the engine failure. So we have your V sub B will be 0. Your initial velocity is given 75 meters per second squared plus 2 times your acceleration. Why it's negative? Because due to gravity, its motion is pa downward. Okay? It's opposing sa ano natin, na-assume na coordinate axis natin, which is yung gravity is pa downward yan eh. So we have your negative 9.81 meters per second squared times S sub B, which is our going to find out, minus 40 meters, which is the initial position from the origin or from the ground to point A. So if you calculate that one, you can solve your maximum height or your position at B or your maximum height to be 326.697 or equal to 327 meters if you round off that. Okay? Nga lang ka-simple or ganun lang ka-simple pag-solve ng position at point B. Okay, so next problem or next requirement is determine thou the rocket's velocity just before it hits the ground using 2.9. Again, so yung kinonsider natin sa A is from A to B. Now, ngayon sa B naman, from B to C. Yung position natin na i-consider ngayon. So, we have B to C. So, what are the parameters that is given at point B and point C? Okay, so point 2.9 again, and we assume that the upward movement or motion will be positive. So, we have V squared over C, sub C, rather, is equals to B squared sub B plus 2A sub C times S sub C minus S sub B. Now, our final position here is at C, so we have denoted our parameters at C as a final position. So, we have V squared C. So, ano yung velocity natin sa C? So, that's our going to find out. So, at V squared B, again, we already know that it is 0. So, that will be 0 plus 2 times the gravity. Now, again, it is downward movement, so it is a negative, times 0 sub SC. Since at at origin man siya, so it is negative, like 0 minus 327 meters. Kasi nasolve na natin to kanina yung maximum height niya, and that's the position at point B. So, we can now directly solve for the V sub C, and that will be equal to negative 0.98 meters per second, or equal to 80.10 meters per second. Now, there's, diba, kung mag-square kayo or mag-solve kayo ng radical, it always give a result plus negative. So, in this manner, since our velocity here is moving downward, we should consider the negative kasi negative pa-downward siya. So, it is negative 80.098 meters per second is equals, or you can round off that one to 80.1 or 0.10 meters per second. Again, take note if yung mga ano nyo, mga what they call this sign conventions nyo, yung mga coordinate, importante din yan kung saan nyo ilalagay yung origin nyo, kung pa upward, downward, left or right. And then again, if you assume na positive yung downward mo, please specify just like this one. So in this problem, we assume that the positive values will be upward movement or upward motion. So again, the important points here is that if you're dealing with free falling bodies, the maximum height of that is at zero. No, the final velocity, its maximum height, or where it begins to decelerate. No, at that point, so ma-assume mo na zero yung velocity niyan kasi biglang huminto, or like that's the that's the maximum height na kakayanin ng object mo kasi may opposing na force, which is your gravitational force. So hindi talaga may maximum height talaga na may reach yung object mo before it falls down. So at that maximum height, you'll assume that your velocity is equals to zero. Okay? And it before it's the ground naman, your position will be zero since we assume here that the origin is at the ground. So that's how you solve for your motion parameters if your rectilinear motion is in free falling manner. So ganun lang yung pag-solve ng free falling bodies. So up next, your part 3 will be in the next video, and see you there.